Good morning, class. We are looking at Chapter 4, Applications of Differentiation, and we start with 4.1, Maximum and Minimum Values. So in this chapter, we cover max and mean, the mean value theorem, how derivatives affect the shape of a graph, indeterminate forms, and L'Hopital's rule, summary of curve sketching, optimization problems, Newton's method, antiderivatives, or integration. Again, as always, it's important to remember the formulas for differentiation. And now specifically that we discussed, the last section of this chapter deals with the anti-differentiation. It makes it that important. So we remember the concept of the differentials. Okay, delta y is f of x plus delta x minus f of x. Okay, that's delta y, and differential is dx for x and dy for y, and dy by definition is f prime of x dx. And we looked at some applications of that. Then we looked at hyperbolic functions, their definitions, identities involved, okay, and the derivatives involving hyperbolic functions. So the synopsis of it can be found here, okay. The inverse function, we just covered that. And again, in a matter of comparison, it'd be interesting to see how they compare when you look at the trigonometric functions, okay. So that's truly interesting to see the relationship between the two and how they compare. So I hope everybody is going to have a chance to look at that, okay. That is for sure interesting to say the least, okay. All right, let's go to new stuff. All right, the very first thing we want to look at is the concept known as a critical point. So what is a critical point? It has a specific definition, everybody, okay. A critical point is defined as a point where f prime is either 0 or does not exist. F prime is either 0 or does not exist. So that is a definition. So having said that, how do we find them? The procedure involves the following three steps, okay. You find f prime, you set equal to 0 to find the solution also where f prime doesn't exist. So starting with a simple example, f of x equals x cubed plus 3x squared minus 24x, we are interested in finding all critical points. The process is very simple. Step one, let us differentiate. Now this is a simple differentiation. Everybody knows how to do that. So let's go through it fast. 3x squared plus 6x minus 24. To set this equal to 0, we need to factor. I'm sure nobody has any problem with the factoring. We factor out the 3. Then we want two numbers. The product is -8 and the sum is 2. And if we set this equal to 0, it results in x equals -4, x equals 2. So this is the bottom line when it comes to this example, finding all critical points or numbers. Now, this last part says f prime doesn't exist. If you look at f prime is a polynomial of degree 2 or quadratic function. Therefore, it exists everywhere, so you don't have to worry about that. But there are functions that we'll see this coming up. All right, let's look at some definitions, okay. We have absolute or global extrema. Extrema is the plural of the Latin extremum, and that refers to max as well as mean. okay? So in short, absolute or global refers to the entire domain, okay? So when we say absolute mean, that means there is a point C such that its y coordinate is the smallest value in the entire domain. So if you look at this graph, this point is a local mean, this is a local max. This point is a local mean, and it happened to be an absolute mean also because there is no other point having a y coordinate smaller than that. Absolute max is the other way around. It's the largest value in the entire domain. We have a local max. We have a local mean. We have a local max. It happened to be an absolute max also. When we say local or relative, it refers to the functional value be the largest or smallest in some open interval, okay? Open interval of A to B. So that's why we have these lines A and B, okay? This is a local mean. This is a local max, okay? And the definition for a local max, again, the same thing, largest number within some open interval of A to B. So this point is a local mean, and this point is a local max. I hope it's clear to everybody. It's fairly simple and straightforward. So those are definitions of extrema. All right, according to Fermat's theorem, okay, if a function has a local max or a mean at an interior point C of its domain and f prime exists, then f prime must be 0. That is extremely important for everybody to follow, okay? If f prime exists, take a look at this, local max and local mean. Class, this the peaks and valleys refer to local max and mean. So local max, local mean, local max, it happened, this one happened to be an absolute max also. Over here and here, f prime exists and f prime is 0. As you see, we have a horizontal tangent line. So f prime does exist and f prime must be 0. On the other hand, here we have a sharp corner. F prime does not exist, okay? So if f prime exists, f prime must be 0. If it doesn't exist, it doesn't exist, okay? Now, this note is important, but it's not necessarily the other way around, okay? Meaning, local extremes in the interior of the function occur when f prime is 0 or f prime is undefined. However, maxima and minima of a function always occur at critical points, but critical points are not always maximum or minimum values, okay? So if something is a maximum or minimum, the points that they occur at, they are considered critical points. But if you happen to have a critical point, doesn't mean you have a max or min, okay? You could or you could not. All right, let's look at this example, something very simple. Y equals x squared, everybody is familiar with. We have an open interval of negative to positive infinity. So this point is a local mean as well as absolute mean, but we don't have a local max or absolute max. Okay. So we do have absolute minimum, which also means local minimum, by the way, because it's an interior point. But we don't have an absolute max or absolute mean. Let's change this to a closed interval. We have the absolute mean, we have the absolute max. And I want to do the writing here. I want to make sure everybody understands what's going on. So let me add a couple of things here. Absolute mean equals 0. at, sometimes they say just x equals 0 or at 0, 0. Absolute max equals 4 at 2, comma 4. Okay. Now, do we have a local max, local mean? No. Okay. And endpoints can only be absolute. Okay. Local has to be in the interior. All right. So I want to make sure everybody's comfortable with that. When you look at this case, because it's half open, parentheses, half close, bracket, then we don't have a mean, but we do have a max. Okay, everyone? What happens here, it's an open interval. The endpoints are not included, so we have nothing. Okay, we don't have a mean, we don't have a max. Why is that? Simply put, they are not included. The endpoints are not included. And so we don't have a mean or max. All right, we have something called extreme value or closed interval theorem. If you happen to have a continuous function, continuity is the key, and you happen to have a closed interval, then f has a max and minimum value over that interval. So we must have absolute max as well as absolute mean. So take a look at what happens here. Absolute max, absolute mean. It happens, okay, in the interior. Absolute max, absolute mean, the endpoints. Absolute mean, absolute max. So one is in the interior, one is the endpoint. Okay. So I hope everybody is comfortable with this. Now, what is the procedure of finding? First, we find the critical points. Then we evaluate the function at those points as well as the endpoints A and B. The largest value is considered an absolute max, and the smallest value is considered an absolute mean. Okay, that's how we arrive at them. All right, so let's start with a simple example. The methodology is given, but before we start, we'll look at the function. What type of a function is this? This is a polynomial of degree 3. Therefore, it's continuous from negative to positive infinity. Therefore, it's continuous from negative 6 to 0. So that's the first thing we must make a note of. And so now we find f prime of x, and so on and so forth. So the first thing is we have to know what's our domain. Now, finding the CPs, first f prime equals 0 or doesn't exist. So if we find f prime, which is a simple process, we get x squared minus 9. And because we want to set this equal to 0, we factor it. And when we set this equal to 0, this gives us negative 3, everybody. Negative 3 is in between. This gives us positive 3. It is not in between. So let's make sure everybody understands what happens here. There are two critical points. We can't use both. Why not? Just take a look at the given interval. And remember, this means an element of, I'm going to remind you. discuss that. That means an element of, this is in set theory, looks like an epsilon. So what do we do? Now plug in -6, plug in 0, plug in -3. That's elementary algebra. I'm going to leave it to you to look at it later on and verify the numbers are right. So plug in the endpoints A and B and plug in the critical point. Now what do we have? Largest number is 18, so absolute max is 18 at this pair. Smallest is -18, absolute mean is -18 at this pair, -6, -18. So take a look at the writing. This is our third step, everybody. This is our third step. So first step CPs, second step evaluate, third step is your writing. So absolute max equals 18 at -3, 18, and absolute mean is -18 at -6, -18. Okay. The next one. What type of a function is this? Can anybody tell us what type of function we have here? F of x is x plus 3 to the power of 2/3 minus 5. What type of a function is that? It's a cube root function. And as you call, cube roots, they have a domain of all real numbers. Any root function whose index is odd, the domain is all real numbers. If it's even, then you have a restriction. So because it's a cube root, odd index, domain is all real numbers. All right, so now let's do the math. We are going to differentiate. So 2/3 sits in front, and then x plus 3 to the power of 2/3 minus 1, and times the derivative of the inside, which is 1, minus 5 results in 0. So 2/3 sits in front, and the exponent goes down by 1, and we rewrite it as such. So here's the expression we have. Now the question is, what happens next? So we did the first, part of the first step, we found f prime. Now we want to find the critical points by setting f prime equals 0 or f prime doesn't exist. So question is, for any fractional expression, a fraction is 0 when, can anybody tell us when a fraction will be 0, class? A fraction will be 0 when, anybody? A fraction is 0 when the numerator is 0, because the numerator is a number. It doesn't matter it's what number, 2 or 200 or 1/2, any number, positive, negative, who cares? The top is a number. F prime can never be 0. F prime doesn't exist. A fraction doesn't exist. A fraction is undefined when the denominator is 0. So f prime equals 0 doesn't give us anything, but f prime doesn't exist gives us -3. I hope you understand what happens here. By the way, again, this is phi, which means no solutions. Phi. This is a Greek letter phi. Okay, class? Which means an empty set. So, again, f prime is 0. You set the numerator equal to 0, it doesn't give us anything. F prime doesn't exist, the denominator equal to 0 and gives us -3. Now let's go plug in. I hope you see this is fairly simple. You plug in -3 and you evaluate. You plug in -5 and evaluate. You plug in -4 and evaluate. Okay. And it gives us those answers. So a quick way of looking at one of them, for example, if I put in negative, by the way, negative 3, I hope you realize negative 3 makes this 0 and it's negative 5. And so let's look at one of them. Let's look at negative 4. If I plug in negative 4 here, okay, so I have, let me see where, I'm going to put here f of negative 4 means, so negative 4 plus 3, okay, that means negative 1. We're going to square it. Let me tell you what I'm using. A to the power of m over n is the nth root of a to the power of m, or the nth root of a to the power of m. And so this, okay, minus 5. Now minus 1, cube root becomes negative 1. Square it becomes 1. And you get minus 4. If you plug in 5, okay, if you plug in 5, okay, so I'm going to go plug in 5 into this expression class. So let me use a different color here. So this expression, if I plug in 5, 5 and 3 gives me 8. So I have cube root of 8 squared minus 5. Cube root of 8 is 2. 2 squared is 4. Minus 5 is negative 1. That's how you arrive at the answer. And the writing is very straightforward, class. Absolute max equals negative 1 at 5, comma, negative 1. And absolute mean is negative 5 at negative 3, comma, negative 5. Okay. I showed you how to evaluate this. This is elementary algebra. You should have no problem with that, but just in case. Okay. So I hope everybody's comfortable with that. All right, we can move on to the next question. We want to find the absolute max and mean. Again, we go through the process, which requires first understanding the domain and range of this function. Okay, so the question is, what type of a function do we have here? I hope everybody can recognize this is a rational function. A rational function is defined as a fractional function where the top and the bottom are both in polynomials. So how do you find the domain of any rational function? You set the denominator equal to 0 and you exclude that. X squared plus 2, because it's plus 2, can never ever be 0. So this has domain, which is all real numbers. So although it's a rational function, there is no restriction and the domain is all real numbers. Okay, everybody? The domain is all real numbers. And so now let's go with f prime of x, which requires the quotient rule. The top gives you 1 times the bottom, minus the bottom gives you 2x times the top over the bottom squared. So I hope you realize, okay, that this is what? X squared plus 2 minus 2x squared, and when you combine them, this is what you get. Okay, everyone, it's pretty straightforward. And now the next step is to find critical points now that you have f prime of x. And to find critical points, remember, f prime equals 0. F prime is 0. The numerator is 0. So you solve that. F prime doesn't exist, the bottom is 0. The bottom, we said we can't have x squared plus 2 is 0. Therefore, when you square it, the same thing. If you put the top equal to 0, x squared equals 2, x is plus minus square root of 2. So I hope you see that this is a simple case. So minus x squared plus 2 is 0. That means 2 is x squared, and that means x is plus minus square root of 2. And so, as you can see, the domain is 0 to 4, so minus square root of 2 is out, just put the square root of 2. F prime doesn't exist, set the denominator equal to 0, it doesn't give us anything. All right. What comes next? Plug in. I hope you see if you plug in 0, you get 0. If you plug in 4, you get 4 over 16 plus 2 over 18, 4 over 18 or 2 over 9. If you plug in square root of 2, the top is square root of 2. This is 2 plus 2, 4. So I'm assuming nobody has any problem plugging in. I hope you see that this is larger than this one. If you don't, you can go with the decimal representation to see that. One easy way to see it is that if you multiply 4 by 2, roughly you get 9. And if you multiply this one by 2, remember square root of 2 is 1.41. So it's 2.82, which is larger. So this is the largest value and 0 is the smallest value. And by the way, 2 over 9 or 4 over 18 or 0.2 bar. Okay. So I'm hoping evaluation is not a problem. Writing is not a problem because remember, in essence, this is what really calculus is all about. F prime equals 0. The rest of it, everything else is algebra that you should be comfortable with. I hope you are. Okay, class. All right, we are ready to move on. We have a lot to do. So I want to go to the next question, class. That one you can do it on your own. Okay, I don't want to do it on that. It's pretty straightforward. Let's look at this example quickly. What type of a function do we have? And that's the question. So I hope you see that you have t square root of 4 minus t squared, which means this is the product of a linear function t and a square root function. So your limitation is the square root, and you need to do the math for the square root to come up with the answer as far as the domain. So rather than accepting this, let's see what is the domain for this one. The restriction is this one. Because it's a square root, what's underneath must be positive. In other words, four minus t squared, which is 2 minus t times 2 plus t, must be larger than or equal to 0. I hope you remember that. And we use sign graph. Okay. The expression is 0 at negative 2 and 2. Then you pick up a test point. And the test point for here would be negative 3, for here would be 0, for here would be 3. And you plug it into 4 minus t squared or 2 minus t or times 2 plus t, whatever is easier. Gives you negative, positive, negative. And right away you realize that according to your sign graph, from negative 2 to 2 is your domain. So if the domain is from negative 2 to 2, that means the function is continuous there. It is also continuous from negative 1 to 2. So you should see that. I hope everybody is comfortable with that. And then let's do the differentiation. Okay. T gives you 1 times the second piece, and the second piece gives you 1/2, 4 minus t squared, by the chain rule times minus 2t, and by the product rule times t. Okay, this is what you get. So one more time, t gives you 1 times the second piece. The second piece gives you 1/2, 4 minus t squared to the power of negative 1/2 minus 2t t. Okay, so this is what you get, and you can combine them into this. How do you combine them? First, notice this is the square root. So let me just put it Where do we, okay, let's put it here. We have the square root of 4 minus t squared minus t squared over the square root of 4 minus t squared, this expression, okay? And so if we take the common denominator, which is the square root of 4 minus t squared, we multiply it by square root of 4 minus t squared, gives us 4 minus t squared resulting in this. This is algebra class, and I hope you are comfortable with that. Now, we set this equal to 0 and see what happens. There are two things we need to look at. F prime equals 0, that means the top is 0. 4 minus 2t squared equals 0. That's a simple case. 4 is 2t squared. T squared is 2. T is plus minus square root of 2. The bottom is 0. That means 4 minus t squared is 0. T squared is 4. T is plus minus 2. So there are 4 answers. I'm assuming everybody can see that. And you need to put it in the given domain of minus 1 to 2. So minus the square root of 2 is out. Square root of 2 is good. Okay. Minus 2 is out. 2 is good. That's why. But just quickly, when we say f prime is 0, that means the top is 0. Okay. F prime is 0, that means the top is 0. F prime doesn't exist, that means the bottom is 0. So inside the radical is 0. So there are 4 answers. Okay, 2 of them are good. By the way, one of them is also endpoint. So now you are going to plug in. What are you plugging in? You plug in -1, you plug in 2, you plug in also square root of 2 to evaluate this. So when you plug in, this is what you get. I will quickly show you how you arrive at it. Okay, class, just give me a quick second. And the writing is, this is the smallest value, this is absolute mean, and this is absolute max. So absolute max is 2 at square root of 2, comma 2, and absolute mean is minus square root of 3 at -1, comma negative square root of 3. So let's see how we do the evaluation. Okay. I quickly explain number 2 because it's the fastest. I hope you see that if you plug in 2 here, 2 squared is 4, 4 minus 4 is 0, everything goes to 0. Okay. -1, if you plug in -1 here, class, this becomes 1, 4 minus that becomes 3, so that is the square root of 3, and remember t is -1 here. So for -1, you get -1 square root of 4 minus -1 squared, which becomes -1 square root of 3. So that's how you arrive at it. Okay. For square root of 2, you get square root of 2. Okay. 4 minus. Now square root of 2 squared is 2. Okay. Maybe I should put it just the way it is, as a square root to the power of 1/2 actually. So I'm looking at t is the square root of 2. 4 minus t squared, that means square root of 2 square root of 2. So I hope you see that you are looking at square root of 2 times square root of 2, which is 2. So believe it or not, those are elementary algebra. I hope you're comfortable with this. So let's move on. All right, we want to graph this function to find the absolute and local extrema, if you will. Local and absolute extrema. I hope you realize if you were to graph this class, basically, I mean, a fast graph, okay, a fast graph. Y equals x squared is like this, right? But the only portion which is good, okay, remember it goes from -1 to 0. So it goes from here, let's say this is -1, to here. The rest is no good. Only this portion, okay? That would be the first part. The second part, let me use a different color, okay? 2 minus 3x, that means y equals 2 minus 3x. And that's a simple case, everybody. Just a graph, okay? If x is 0, we get 2. If y is 0, we get 2/3. Okay. So we get something, this is not to scale, but we get something like this, only this portion from this whole, okay, all the way to x is less than or equal to 1. Assume this is 1, by no means this is to scale, so you have this. So this is the graph. So I hope everybody can see how we graph it. Obviously, what I have is not to scale. This is much better. So as you can see from the graph, okay, the only thing that we have is an absolute mean, everybody. This is an absolute mean, okay? So absolute mean, okay, is the y coordinate for this one, okay, which is -1 at 1 minus 1. We don't have anything else. We don't have an absolute max. We don't have a local max. So remember, the max supposedly is here, but it's a hole that is out. So absolute mean, local. So the only thing that we have is an absolute mean and nothing else. Okay. So I hope everybody is clear as to how we arrive at the answer. All right. So from the graph, we can find the extreme. Okay. All right, let's do the same thing here. I'm just looking at the function, which is slightly different now. Okay. Now the function is a combination of trigonometric function sine and cosine. There is no restriction. The domain is all real numbers, and therefore it is continuous also from 0 to pi over 2. So y negative to y of infinity, f is continuous because it's a trigonometric function. So you want to make a note of it. Okay, trig functions. F is a trig function. Is a combination of sine and cosine. So there is no restriction, all real numbers. All right, so let's go with the first step. CPs, that means we have to go with f prime. So when we differentiate this 2 times, cosine gives us negative sine, and then plus sine gives us cosine 2t, and then times 2. So one more time, 2 times negative sine, so negative 2 sine. Sine gives us cosine 2t. By the chain rule, we need the 2 times 2. So this is f prime of t. And what we can do, we can set this equal to 0 to solve. And to do that, notice this is cosine 2t. Now, what is cosine 2t? Cosine 2t, okay, is cosine squared minus sine squared. 2 cosine squared minus 1. And 1 minus 2 sine squared, all of the above class. Okay, let me just quickly remind you. So cosine 2t equals cosine squared minus sine squared equals 2 cosine squared minus 1 equals 1 minus 2 sine squared. All of the above. And I hope you see that why we are using 1 minus 2 sine squared, because we want to solve this, and this is sine, everybody. Because this is sine, we change this to sine. We use the last one. So if you factor out the -2 and you put it in descending order, okay, I want you to write this as, let me just write at top of it. Write it as -2 sine t plus 2 minus 4 sine squared t. Put it in descending order. That means this becomes the first term, and then take out the -2. Why are we doing that? Because we want to be able to factor it. I hope everybody is comfortable with factoring this. Okay, so -2 remains, and you factor this into 2 sine t minus 1 times sine t plus 1. Okay, so that's a simple factor. All right. We set this equal to 0. That means 2 sine t minus 1 equals 0, and sine t plus 1 is 0. This one means sine t is 1/2, and that means sine t is -1. So each one equal to 0. I'm looking at trigonometric functions. I hope you see that. We are practically done here with calculus, and now the rest is, in this case, trigonometric functions, dealing with trigonometry and algebra. Okay. Sine is 1/2, okay, and we are going to go from 0 to pi over 2. The only possible answer is pi over 6. Sine is -1, okay, so the only possible answer is minus pi over 2 or 3 pi over 2. It's not in the interval of interest. So t equals pi over 6, t equals pi over 2, but this is the only acceptable answer. Minus pi over 2 is not acceptable. By the way, you can write 3 pi over 2 if you want. All right, class. And so let's quickly recap. We are solving for t when sine t equals 1/2, okay, we get pi over 6. When sine t is -1, we get negative pi over 2, which is not within the given domain. So now we plug in 0, we plug in pi over 2, we plug in pi over 6. I'm assuming everybody can do the math here. Okay, so if we plug in 0, okay, cosine of 0 is 1, 2 times that is 2. Okay, sine of 0 is 0. If we plug in pi over 6, okay, then 2 cosine t, 2 times cosine of pi over 6, which is square root of 3 over 2, and then sine of 2t, or 2 times pi over 6 or pi over 3, which is also a square root of 3 over 2. We get 3 of those. I will show you this one in a moment. If you plug in pi over 2, I hope you realize that cosine of pi over 2 is 0, everybody. Sine of 2 times pi over 2, that means pi is also 0, and we get 0, and here's the writing. So I will show you one of those calculations in a moment. So if I'm interested in calculating for pi over 6, everybody, for pi over 6, we put 2 cosine of pi over 6 plus sine of 2 times pi over 6, that means pi over 3, everybody. Okay, which is 2 times square root of 3 over 2 plus square root of 3 over 2. That means we have 3 of them. Okay, that means we have 3 of them. I hope everybody's comfortable with that. Okay, we have 3 of them. Now f of b equals f of pi over 2. Let's just also do this one with a different color. So for this one is 2 cosine of power 2 plus sine 2t, sine of pi, everything is 0. Please understand, we put it back into this original function and evaluate. So I hope you realize 3 squared of 3 is divided by 2 is the largest. If you can't see that, go with the decimal representation. Remember, square root of 3 is about 1.7. Okay. And so the smallest one is 0. There you have it. It's very straightforward. All right, let's look at the next example. We want to find critical numbers of this function, f of x equals x to the power of minus 2 times ln x. Okay. And so it's a product rule in order to find f prime of x. This is minus 2 x to the power of minus 3 times ln x, and ln x is 1 over x times x to the power of minus 2. Okay. So this one is the same as x to the power of negative 3, so we can factor it out. So when we factor x to the power of negative 3, we can rewrite this as such. All right, so f prime equals 0, f prime doesn't exist. F prime equals 0, the numerator is 0, 0, f prime doesn't exist, the denominator is 0. So if you set the numerator equal to 0, okay, that means 2 ln x equals 1, ln x equals 1/2, and x is e to the power of 1/2, or square root of e to the power of 1/2. And you can leave it as that because it's a precise answer. E to the power of 1/2, leave it like that. It's the same as square root of e, okay? And the denominator equal to 0, x becomes 0, okay? F prime doesn't exist, the denominator equal to 0. However, we can't accept that. Why is that? Because when we go back to the original function, okay, the original function I hope you realize the domain is 0 to infinity. Why is that? The top, the domain is 0 to infinity. That's the restriction on natural log. The bottom, the only restriction is x can't be 0, but the top has a more restricted restriction, and therefore 0 to infinity is the domain. That's why. So this is the domain 0 to infinity class. That's why. And so having said that, let's look at the last question. We want to find the absolute max, okay? And we are going to go through the same process again. This is a continuous function from negative to positive infinity because this is a linear function. This is tan inverse, as you call the tan inverse has a domain all real numbers. So the domain is all real numbers. Okay, so let's differentiate piece by piece because we want to find f prime of x. So x gives us 1 minus 2 times tan inverse gives us 1 over 1 plus x squared. So x gives us 1 minus 2, and then tan inverse gives us 1 over 1 plus x squared. Okay. So if we set this, by the way, this minus 2 times that comes up 1 minus 2 over 1 plus x squared. To set it equal to 0, we can do it like so. Right? I hope you realize why. And the cross product, that means 1 plus x squared is 2. Subtract the 1 and get x. There are two answers. X is plus minus 1. And x is only 1. Why is that? Take a look at the given interval. The given interval of 0 to 4 Can we use 1? Yes. Can we use -1? No. That's why you use only 1. Now, your next step is to evaluate, okay? If you plug in 0, that's 0 minus 2 tan inverse of 0. You may remember tan inverse of 0 is 0 because tan of 0 is 0. So that gives you 0, okay? If you plug in 1, you get 1 minus 2 tan inverse of 1. Now, tan inverse of 1 was pi over 4 because tan of pi over 4 is 1. So minus 2 times that gives you minus 2 times pi over 4 or minus pi over 2. And 4, you just write 4 because that's a precise answer. Now, I hope everybody's comfortable with the concept. We are evaluating, okay? Now, you have to use a calculator to come up with that as an approximation. I hope you realize this is negative because pi is 3.14. You divide it by 2, okay, it's about 1.7. So this is negative, 1 minus that, okay? So far, and this one, I don't know the answer. I have to use a calculator. So in both cases, when you use a calculator, so this becomes about negative 0.57. That's straightforward. And the last one becomes positive 1.35. Therefore, the largest would be this, the smallest would be this. And here's how we do the writing. Absolute max equals 1.35 at 4 comma, this is the precise answer class, or you can say 4 comma 1.35. Again, you could say 1.35 here, and over here you can say negative 0.57, roughly.